Hello, today is the lab number 5. Today we're going to study summing amplifier. It's another type of the amplifier. The configuration is a very basic one. The summing amplifier is used for summing the input voltages. So for this configuration we need to have, this time actually we have to have two inputs. So you have to connect to BNC to the signal generator, connect this to BNC to two resistors. So let's say one input we connect to the 1K and another input we connect to the 2K resistor, and have one feedback resistor to the 10K. So as you can see, these two resistors, one from one input, from one signal generator, from another signal generator, and this red line is 10K is a feedback from the output to the 10K. So we have 10K feedback resistor, 1K input resistor, and 2K another input resistor, and connect this everything to the inverting input, and positive goes to the ground. So set your signal generator. So try different frequencies and see the effect of different frequencies. So for initial point you can start with, let's say, 500 Hertz, and each signal should have like one peak to peak voltage. So turn on both signals on the signal generator. Set your voltage supply. You can put 10 or 20, but no more than 20. So then, since everything is connected, the output goes to the oscilloscope. So turn on your biasing and turn on your signals. As you can see, so we have two input. We still set to input signals for 1 voltage, but in output we are getting 13.5, almost 15 voltage. The reason is we actually sum up two voltages, like 1 voltage plus 1 voltage, and since we have also the gain, since we have like 10K volt, like the resistor to the feedback resistor, so we have amplification. So basically this is how it should work. If you calculate using the formula, so that which is provided in an example on the lab work on number 5, so we can see that. So if we calculate gain for each resistor, so for resistor 1K, gain is going to be 10, since 10 divided with 1 is 10, and the gain for the second resistor 2K is 5. So 10 divided by 2 is 5. So gain for one resistor is 10K, for another is 5K. And the output voltage is going to be sum of the gain of each input voltage. So 10 plus 5 is going to be 15. But we are getting almost 15, so we like losing like 1.5 voltage, but it's in experimenter it's fine. It's due to the imperfection of our connections. See so many resistors, the jumpers we have, so some voltage drop we're gonna have, but this is working as it should be. So this is how the summing amplifier should work. You should also repeat the same configurations. Try to use different frequencies and see how actually it depends how it's affect the amplitude. And also try to sum up different resistors, not 1K, 10K and 2K, but also try to sum up, like for example 4K and 1K, or 4K and 10K, or 2K and 4K. So you can see how actually the summing the voltage is going to be in output, and check it and compare it with your theoretical calculations. So what we did now, we did the summing amplifier for inverting input. So try it the same but for the non-inverting. So before I connect the negative, now you do the same but for the positive, according to the figure for the lab the document. So now what we gonna do, so now let's try to do the differential amplifier or subtractor amplifier. Before we did the summing amplifier that sums input voltages. Now we're gonna do it is to make a subtractor or differential amplifier. So what you have to do, you have to just arrange the connections. So now we're gonna involve two inputs. For the negative input you're gonna connect the 1K resistor, so it goes to the signal generator A. For the another positive, we're gonna also use 1K resistor, and feedback for the negative is 2K, and feedback for for the negative should be also 2K. So 2 resistors feedback for the negative and positive is 2K, and for input resistors 1K, 1K. Then connect like the 1 volts to peak for the negative, and for the positive connect 3 volts to peak to peak. So what we're trying to do now, we'll try to like subtract 3 voltage from the 1 voltage. And according to formula, 3 minus 1 is 2, and since we have 2K feedback and 1K input, so gain is 2. 2 times 2, it should be 4. And as we can see, we're having the 4 voltage output. So try to do the same topology, same circuit. Try to actually subtract different voltage and see how they work. Are they correct? Are they corresponding to the experimental results, corresponding to the theoretical results? Try using different resistors and see how the substructure or differential amplifier is working.